So today, still working with quadratics, okay? So when you guys did the poster project and when you did the quiz, right? We were looking at the graphs. We were looking at graphs in their three different forms: factored, so, vertex, and standard, right? Those are the three forms. Today, what we're going to do is we're not going to look at the graphs. We are going to do two things: factor, solve. Factor and solve them. Okay, so we're not going to really worry about the graphs today, but it still has parts that you're used to, right? Standard form has an A, has a B, has a C, right? Today, we're just going to deal with things in standard form. We're not going to see other forms. We're not going to see vertex form. We're not going to see factor form, okay? So that's what we're going to deal with. So essentially what we're doing is factoring them. Factoring is another word for division. We're just dividing them, okay? Or opposite of multiplication. More opposite of multiplication than anything, okay? Then the zero product property. Zero product property. Remember when we did our posters, our quiz, our notes for last section, and we said P and Q are liars. We're like, P and Q are liars. Why are they liars? Because of the zero product property. That's why they're liars. And I'll explain that when we get to it. But that's the reason why. I told you, I was like, they're liars, but for right now, don't worry about it. I'll tell you why next week. Today, I'm going to tell you why. It's called the zero product property. Okay? So when we factor, we have 3 steps for factoring. 3 steps for factoring. Sometimes they want us to also solve. That includes a 4th step. So if they want you to solve, you got to use all 4 steps. Okay? If they only want you to factor, you just use the first 3 and you're done. So it just depends on what they want you to do. Okay? That just depends on what the question is asking. All right? Okay, so example number 1. Let's go look at example number 1. Factor the trinomial. So we have the word factor in it. So we're going to use the first 3 steps. Okay. Why is this called a trinomial? This is a trinomial. It is. Why is it called a trinomial? Why do you guys think? I'm sure you guys know. Why? Yeah, Bruno? Exactly. There's 3 parts, right? Yeah, there's 3 parts. The first part is x squared. The second part is negative 2x. And the third part is negative 8. Okay. Okay, so factor. Step 1. If there is an equal sign, set it equal to 0. If you are able to. Well, this one does not have an equal sign, right? So we can't do anything there. So skip step 1. Step 2. What is A, what is B, and what is C? So let's do that right now. Let's set what A is equal to, what B is equal to, and what C is equal to. Okay, so by looking at this guy, what is A going to be equal to? Positive 1, right? The number in front of x squared. B, negative 2. C, negative 8, right? A, B, and C. That's step 2. Step 3. Step 3, I'm sure you've seen before. It'll look familiar when you see it. It looks like this. It's got an X, right? It's got an X. The top has a multiplication dot. The bottom has an addition symbol here. Okay. So how do I fill out this X? So there's going to be things that go this one, all of these. We're going to fill out all of these. Okay. So we start with the top and the bottom of the X. See that multiplication here? How do we get our number here? Well, we get our number here by multiplying A times C. A times C. So if I were to multiply A times C, what number would I get? If I were to multiply A times C, what number would I get? I'd get a number. What number would it be? Negative 8. That goes on top. Whatever B is, positive or negative, it always goes on the bottom. So B is negative 2. So I'm going to put negative 2 down. Okay. Now what I have to do is figure out what goes here and what goes here. That's what I have to figure out. So how do I do that? Well, you play a little game. It's called the X game. or the diamond game. You say, all right, well, what numbers multiply to be the top number, but add to be the bottom number? So what numbers, before we do that, what numbers multiply to be the top number? What numbers multiply to be -8? We have 4 and a -2, right? We can also switch those, right? And make it -4 and +2, right? We have -8 and +1. We have -1 and +8. And I think that's the only things that make -8 multiplication-wise, right? Which of those also add up to be -2? First one, second one, third one, fourth one. Okay, right there. -4 plus 2 is -2. So it fills both criteria. They multiply to be -8, and they add to be -2. Those are our two numbers. So we write them down. -4, +2. That's the X, or the diamond. Some teachers call it the diamond, some teachers call it the X. It's the same thing. Now the last step, it's part of this step, is using what's called the multiplication, or not the multiplication box, the box. The box has got 4, looks like a window. It's got 4 sections. Some teachers, some Math 2 teachers use the multiplication, this box. Some teachers don't. So that's why I want to, this is kind of a, hopefully this is kind of like I've done this before. Hopefully, if you remember it, that's done on purpose. Okay. It won't always be that way, but for today, I kind of wanted to start with something that looks familiar to you, because as we move on, it won't look familiar to you. So start with what you know. Okay. So how do we use this? How do we use the box? Well, A, whatever A is with its x squared. So this guy right here, 1x squared, always goes in the top. So 1x squared always starts there. So this guy always goes there. This guy, C, always goes last. So -8 goes down here. What goes in the other two? These guys right here. Does it matter which one goes first and which one goes second? No. I could put -4 and +2, or I can put 2 and -4. It doesn't matter. Here's the thing, though. This is the first term, right? This is the last term. These two guys combine to make this guy right here. So, but they're missing something. What do they need in the box? An X, right? Yep, they need an X. That's how we get them. A is by itself, C is by itself, and B is kind of split up. Okay. So now what we do is reverse multiplication. So I have 1x squared here, right? 1x squared here. So I have to think, what times what will give me 1x squared? Well, let's start with the x. What times what gives me x squared? What times what? What times what gives me x squared? Yeah, x times itself. That's why it's x squared, right? And then 1, right? 1 times 1 makes 1. So you can put the 1 here and here. You don't need to, but you can if you want. Okay, now let's go to the next one. What would go here to make this times this equal this as my answer? What am I missing up top? What am I missing up here that would make these guys equal that? -4, right? So that means a -4 or a -4. One last stop right here. X times what gives me 2x? What am I missing? +2. I don't need an x there because I already have an x here because it's this times this to make that. If this was x squared, yeah, I would need an x here. Yeah, absolutely. Yeah. Okay, so you'll know you did it right because the last box will make sense. This times this makes -8. Yep, that's right. So I know I did it right. Okay, so what we have here is a factored version of our answer. So we're going to write it in parentheses. X minus 4, x plus 2. Both of those guys in blue mean the exact same thing. It's a factored version. The top, we know the top right here. This guy up here is in standard form, right? Which form does this guy look like it's in? We've seen that before. Factored form, right? It's the factored version of it. That's how you get from standard form to factored form. You do these steps, okay? That's how you switch from one form to the other. They don't say that, but that's essentially what we're doing. We're factoring it. So the blue guys, this guy up here and this guy down here, they mean the exact same thing. Kind of like how all of these guys were the same as -8, right? They're all the same. They're just factored versions of it. Okay? So on Delta Math, what would you do? I'd put one box and write your answer just like that. Parentheses, x minus 4, parentheses, x plus 2. Enter twice, you're done. Green check. Okay? That's if it says factor. If it says solve, we have an extra step, but we don't have to do that for this one because it just said factor. Okay? Let's go to example number 2 now. Okay, so example number 2, again, says factor. So set equal to 0 if we are able to. There's no equals to 0. There's no equal sign, right? So we can't. All right, let's move to the next step. The next step says A equals, B equals, C equals. We got to find out what A, B, and C are. Well, A is 1, B is +2, C is -24. You just come from here. Okay. Now we go to our X. The top is multiplication. The bottom is addition. So the top, A times C. Top is always A times C. Well, -24 times 1 is just -24. The bottom is always going to be just B by itself, positive or negative. So this one's a +2. So now I got to play that X game again. What two numbers multiply to be -24, but when I add them together, they also equal 2? There you go. -4 and +6. When I multiply those two guys, I get -24. But when I add them together, I get +2. That's, I don't want to say the hardest step, but it's the step that gives you probably the most pause. Okay? The reason, if you're kind of stuck there, make a list. Make a list. See, 12 times 2, -12 times 2, -2 times 12, 24 times 1, -1 times 24, 6 times 4, negative. Make a list like this. -8 times 3, -3 times 8. Make a list like that. Okay? And then you'll see which ones add up to be 2. The only one that would add up to be +2 is this guy right there. Okay? So if you're stuck on that one, make a list. It takes another 30 seconds, a minute, but it helps you. Okay? All right, so now let's go to the multiplication, or I keep calling it the multiplication box because sometimes it is, sometimes it's not. Today it's the factor box, factoring box. Okay. A with its x squared goes in the top box, the first box. C goes in the last box. The two things that I found out here go here and here. Order doesn't matter for these two guys. As long as they're in each of those, it's okay. And then remember, they need an x because when we add them together, they have to make +2x. Reverse multiplication. What times what makes x squared? X times itself, right? X times what makes negative 4x? Well, I already have the x, so I'm just missing the minus 4. X times what makes 6x? Well, I already have the x, I'm just missing the positive 6. I know I did it right because negative 4 times positive 6 make negative 24. So the factored version would look like this. So I put my answer just like that in the delta mass. This guy and this guy are exactly the same. They're just in different forms. One's in factored form, one's in standard form, but they say the exact same thing. They have the same vertex, the same axis of symmetry, the same all of that stuff that you guys did last week. Okay? We're just doing that on the poster. You did that using the graph. Today we don't have the graph. So we're doing it using another way, factoring. Okay? All right, so let's go to example number 3 now. Example number 3. So this one we add in the word solve. Be careful, because it also has the word factor in it too. So I asked students, I'm like, what are you doing on this one? And they're like, I'm not sure if I'm factoring or I'm solving. If it has the word solve, you're solving. Doesn't matter if it has factor in it. These guys up here did not have the word solve. Number 1 and number 2. They just had the word factor, right? If it has the word solve, you're solving. So now we got to add in the step at the end. Well, that's the thing. The first 3 steps are the same. Step 1. Okay, Mia, do I have your focus up here? Okay, here we go. First step, set it equal to 0. Right now it's not equal to 0. It's equal to 9x. So what do I have to do to make it equal to 0? How do I turn 9x into 0? By subtracting it. Whatever I do to one side, I got to do to the other. That makes a 0 over there. Okay, good. Equals 0. Now the 9x, can I subtract it from 18? Can I subtract it from 1x squared? Can I combine some like terms over here? No, because it's not a like term. It goes right in the middle of those two guys. X squared minus 9x plus 18. It becomes b. Okay. That's step 1. We had to do step 1 right now. We haven't had to do it before, but that's how you do step 1. Step 2, ABC. A is 1, B is negative 9, C is 18. Step 3. Okay. A times C goes on top. What is A times C? 18, right? 1 times 18. B goes on the bottom. That's negative 9. So now I have to come up with the numbers that multiply to be 18, but add to be negative 9. So they have to multiply to be a positive number, but add to be a negative number. What 2 numbers is that going to be? See, 9 and 2, 6 and 3, 18 and 1. None of those numbers add up to be a negative number. So what do I need? Make them negatives, yeah. Negative times a negative makes a positive, so I can also do that. So negative 6 and negative 3. Okay. So now I go to my box. It's got 4 sections, just like always. So A with x squared goes on top. C goes on bottom. and then negative 6x, positive 3x, or sorry, negative 3x. Now, what times what makes the inside? I always start with x squared because it's going to be, to make x squared, it's just going to be x times x. Then over here is a negative 6. Over here is a negative 3. Negative 6 times negative 3 make 18. Okay. So I have x minus 6 and x minus 3. Factor. But here's the thing, it didn't say factor. It didn't say just factor. It said solve it. So that means I'm going to have to use the last step. So remember, these two guys are the same. So with solving, because I had an equal 0, I have to put equal 0. Solving means I have to continue. Okay, so what this means is, this is multiplication here. This times this equals 0. Well, what do we know about things when we're multiplying? When we're multiplying, when we're multiplying, right? And we get 0 as an answer, what's the rule? If we're multiplying two things and I get 0 as an answer, what is the rule? Or what had to have happened? One of them had to be 0, right? There had to be a 0 here or a 0 here. Well, zero product property says you don't know which one is 0. So you have to assume they're both 0. So that's why we do the last step. Set them both equal to 0. So x minus 6 equals 0. X minus 3 equals 0. Solve. Solve for x. So I'm going to get two answers. Add 6 to both sides. I get positive 6. Add 3 to both sides. Positive 3. What's another name? What do we call those guys? What do we call these guys? Let's see. Let's see if we remember from last week. What do we call these guys here? Does anyone remember? One thing is x-intercepts. Another one is roots. Another one is solutions. Another one, the other one was zeros. These guys are P and Q. These guys are also P and Q, right? Didn't we say that P and Q are liars? That's why they're liars. Because it's not negative 6, it's actually positive 6, and not negative 3, it's actually positive 3. We just didn't do this step last week. This step I hadn't showed you last week because I'm like, I'll show you guys next week. So I just said, for now, they're liars. Now, when we do this step, now you know why they're liars, right? Now you know why they're liars. There's a reason behind that, because of the zero product property. Okay? All right, so if it asks you, so this question, sometimes they ask you this. They'll ask you the same question, but instead of solving, they'll say, find the x-intercepts. Well, isn't that what we just did? Right? So it's the same thing. Find the roots. Do the same thing, right? Sometimes they'll get tricky on you and they won't say solve. They'll say find the roots, find the x-intercepts, find the solutions, find the zeros. You just did that. That's all you did. You just did that. Okay, so it's the same thing. Okay, so don't let the wording confuse you. All right, number 4. Try number 4 on your own. Try number 4 on your own. I'll give you a few minutes, and then we will talk about it. So when you're solving, when you're setting it equal to 0, which side do you use? This is what I say. Keep A positive. We always want A positive. Is it wrong if A is negative? No, but it just makes your life harder later on. So keep A positive. Whatever side keeps A positive, that's the side I would go with. Okay? So if A is positive, that's the side I would go with. Okay? Because if you did it on the other side, you would get negative x squared minus x plus 2. That's not wrong. That's right. But then a would be negative 1. And it would it cause some issues down the road. So to avoid those issues, just always keep a positive. Okay, so I got A, B, and C. So let me finish to catch up to where you guys are at. Multiplication, addition. So I got negative 2 and positive 1. So the two numbers there's not a lot of numbers that multiply to be negative 2. Negative 2, positive 1. Negative 1, positive 2. That's it. So which of those make positive 1? Negative 1 and positive 2. Go to the multiplication or just the box, the reverse multiplication box. So we have x squared, negative 2, positive 2x, negative 1x. Right? Because a with x squared goes up here, c goes down here, and then the two guys go in here and here, and we tack on an x. Okay, so reverse multiplication, x times x, positive 2 minus 1. So I get x minus 1 and x plus 2 equals 0, because it's the same thing as this guy here. So I have to set it equal to 0. Solve, set them equal to 0, and solve. So I get x minus 1 equals 0, and x plus 2 equals 0. Add 1 to both sides. Subtract 2 from both sides. I get 2 answers. Delta math, so you need 2 boxes on delta math. One of them would be 1, and one of them would be negative 2. On delta math, you don't have to put the x equals. So it would just be 1 and negative 2. Those are your 2 solutions. Those are your 2 x intercepts. Those are your 2 roots. Those are your 2 zeros. Okay. All right, so number 5. I kind of turned it on its head. Sometimes I'll do this. Sometimes I'll put these on here because these are photo math proof. You can't use photo math to solve this one. You have to know something about it. All right. So sometimes I'll use these. I'll use these types of problems. If I feel students are using photo math a little too much, I'll throw it like this. The problem with that is, I think everyone would say this is a harder problem than this, right? So that's the thing. So that's why I'm saying, like, with photo math, careful with photo math. I don't mind if you use it, but if you're using it for like more than 20% of the time, then it's too much. That's why this type of question was created. Okay, so this type of question says, okay, a student finishes the problem. They have a quiz on this. They finish the problem, they get 2 answers. They get x equals negative 7 and x equals 4. My question is, where did they start with? Where did they start with? How do we do that? Exactly. You have to start with step 4 this time, right? You can't start with step 1. You got to start with step 4. Okay, so let's put it back in factored form. Good. So what would it look like in factored form? Good. Good. That's the first step. First step's the hardest because once you know what to do, then you're good. So before this, right, we got x plus 7 and x minus 4 from the box. So let's set up the box. That's where we got these two guys from, right? So what's going to go in the box? Or actually, what do we know about it right now? Do we know what's inside the box? Do we know what goes inside here and here? Not yet, but we do know what? What goes on the outside? We know an x plus 7 had to have been here or here, and an x minus 4, right? Then we use multiplication. X times x makes x squared. 7 times x makes 7x. X times negative 4 makes negative 4x, and then negative 28, right? So that means the equation had to have been x squared. We know c. C goes in the bottom, so negative 28, right? What was b? Something x. What was b? It's not going to be, you're close. It's not going to be 2. These are my answers from the diamond, right? 7 and negative 4. So they had to multiply to be what? Negative 28. And then they had to add up to be, what did they add up to be? That was the original equation. That was the original equation. Okay. A is 1, B is 3, C is negative 8, or negative 28. Okay. Same steps, you just did them reverse. You had to go up the ladder instead of down the ladder. Okay. All right, so we got some time. We got about 20 minutes. I want to do one more problem in your notes. So wherever you are going to put this in your notebook, let's do one more problem and then we'll be done. This will be example number 6. Solve by factoring. Okay. I'll give you some time. Go ahead. Okay, so this guy, when I set it equal to 0, something goes away. Not only is it equal to 0, what becomes 0? C becomes 0, right? Still got a C. It's just 0. Okay. So A is 1. A is 1. B is negative 8. C is 0. That doesn't change the next step. Multiplication, addition. If I multiply A times C, I get 0. If I multiply, or if I add up, it's going to be negative 8. What are the two numbers that multiply to be 0 and add up to be negative 8? 0 and negative 8. If I multiply those two guys, I get 0. If I add them up, I get negative 8. Okay. Go to my box. I'm going to have x squared plus 0. And then I'm going to have a 0x and a negative 8x. X times x plus 0 minus 8 equals 0. Set them both equal to 0. X minus 8 equals 0. X plus 0 equals 0. So one of them, I add 8 to both sides. So I get 8 as an answer. And the other one, I subtract 0 from both sides. I get 2 answers, 0 and negative 8. Or positive 8, sorry. 0 and positive 8. 0 is an answer. 0's on the graph, right? If 0's on there, so just if you get 0, don't think it's just not an answer. No, it is. There's 2 answers on this. Okay. Just because C is 0 doesn't mean it's a number. Okay. All